We are going to take notes on Newton's laws. There's 3 of them. So, law number 1. Not to be confused with the Lorentz in our class. Does anybody remember what the first law is? If not, look back on page F41. Tell me, what happens to an object at rest? What happens, Thomas? Unless what?
Unless an outside
force
pushes.
Okay. An object at rest stays at rest. Unless it is acted on by an outside force. And what? What's the next part? Thomas, are you the only one that knows anything today?
I'm trying to write.
You will have plenty of time to write. Meanwhile, Thomas is answering all the questions. Go ahead, Thomas.
And it's in motion. It stays in motion unless an outside force stops.
Very good. And an object in motion stays in motion unless it is acted on by an outside force. Case in point, you have a grassy knoll right here, and you have a blue ball just sitting there. The ground is level, and the children left it outside. The law says, what is that ball going to do? It's going to stay put unless something acts on it. That's law kicking the ball.
It looks like they're running away.
Hey, leave it alone. He kicked it and ran away so he wouldn't get in trouble. Don't talk about my picture. I'm not judging your stick figures.
It looks like he's trying to kick the grass too. Yeah.
Well, that's like to show that it's now, second picture. I don't need to hear any more talk about my terrible picture. Thank you. Have you ever seen The Wizard of Oz? Here goes the Wicked Witch to go get Toto.
I actually did this on
Yeah, Toto is.
We had to
Oh,
watch it,
nice.
and we had to take a test on it and see what we could remember.
There goes the Wicked Witch to go get Toto. Don't worry, that'll be the next thing we watch during lunch. She is well on her way to getting the dog. But then, all of a sudden, she hits the rock.
Oh no.
The bicycle stops.
You should make a scared face.
She goes down and breaks her head and goes to the rock.
She keeps going that way. The bicycle stops. The bicycle stops. She does not.
And she actually drowns down to the pavement and hits her head and dies.
Law, I don't need all these graphic details. Okay, law number 2. In 5th grade, we talked the least amount about law number 2. But law number 2 says that acceleration depends on the size and direction of a force acting on it and the mass of the object. So basically, force equals mass times acceleration. Now let's break that down into easy to understand words. Because I like stuff to be easy to understand, don't you?
Yeah.
So let's make this easy to understand. How easy or hard it is to start or stop an object depends on the size and direction. Number 1, the size and direction of the acting force. And number 2, the mass of the object. This is like what we talked about yesterday. If I have 2 objects, a controller and a pen, and I flick it with my finger, which one's going to be easier to move? Now watch. Ready? Now, ready? This is going to hurt. Which went farther? Okay? Because I used the same amount of force for each in the same direction, but the mass of the object decided which one would go further. So I'm gonna pretend like I've got a cart. I do have a cart right here beside my desk. And on top of my cart, I'm gonna put a little micey, a moose. And then on my cart,
Legs.
Spider? That looks like
A mule. Legs.
a llama. A Chipotle.
well, y'all said a moose.
And a moose. Its stomach looks like a door. It does.
I don't see a moose. Oh, I see it now.
Is it a mouse or a moose? No, that's his front legs. He's sitting like this. Okay?
A moose.
Which one's
And
the
then there's his back looking like a deformed elephant.
Stop talking about my drawing, Evan. Okay, here's a mouse. And here's a moose. And I'm pushing both with the same force. But which one is going to be easier to move? The mouse is going to be easier to move. Why? Because the size and direction of the acting force, I'm pushing on the cart the same, but the mouse has a smaller mass. The mouse has a small mass. The moose has a big mass.
The moose be big.
Okay, I am tired of hearing all this sidebar conversation. Let's stay on task, please. And then, of course, there is the third law. Law 3. Every action has an equal and opposite reaction. So, who's going to be going to West Lincoln? Okay, at West Lincoln, they have this beautiful thing called a cannon. And they fire it at the football games every time they score.
Oh, yeah, actually, fireball beetles.
And loud.
Very loud.
Have you never heard it, Lo?
I have. I've never been there.
I have. And it's very loud. It's really loud.
Okay, watch. When the cannon fires,
It hits the moose.
boom, this way. What happens to the cannon?
It disappears.
It's all confetti. It like moves. Boom. It backs up.
Because of that blast, the cannon moves this way. Another example would be when they launch a spaceship on their mission to Mars or wherever they're going.
Mission
He says, I'm ready. I'm ready.
Earth.
I'm ready.
Among
A
Us.
place where every mask is pulled down below their nose.
Among Us. Never mind.
This force pushes out. I got a good comparison. Who was here when we watched the BFG? And that he drank the frog scottle and the gas pushes out and it pushed him up.
Wait, I think ball is gone.
Out of Snozgumbers.
What happened?
Okay. So get that down, please.